Hello, welcome back, students. In the previous videos, we have seen the solutions to question number 1, 2, 3. And the question number 3, I have given three different solutions. Think that will give you a solid foundation in understanding the set theory and solving the problems algebraically through Venn diagram or assuming some values. So now we'll move to the fourth question. This says, show that the following four conditions are equivalent. A is a subset of B, the first condition. Then A minus B is a null set and A union B equals B and A intersection B equals to A. We'll do one by one. We'll make set first the sets. One set A and the second one B, which is B. This portion is the intersection part. This is nothing but A intersection B. Right? Now what you have to show is what is given is first one. A is a subset of B. That means what? A is not clearly exactly like this. A is, suppose this is B, A is something inside. This is A, is completely inside. A is a subset of B. All the elements of A are inside B, right? So what is now A minus B? What is A minus B? A minus B equals to, so what are the elements of A and remove from them all the elements of B? See, remove all the elements of B from A. What is left out? Nothing. All the elements are including in B also. So we remove everything. It is left with null set. So this is second one is A minus B equals to 5 is equivalent. One and the same. Third one, A union B. What is A union B? You can say A is inside B, right? A, all the elements, union with B. B is having all the elements of A also. So A union B becomes what? A union B. B itself, right? That means A is union B is what? A elements and all the B elements. But B is having all the elements of A inside it. So A union B is B. This is another, this is also equivalent. Fourth one. This is A intersection B. What is A intersection B? A and B. What are the common elements of A and B? Obviously, this is the common elements. The rest of the elements B, what are the elements outside A are not common. Only A is common with A intersection B. What is A intersection B is? A elements of all elements of A. A intersection B equals to A itself. Right? That's it. This is not needed. I will draw it again in the next question. This is very important. I will give you explaining the basic relation what I shown in the previous videos. So we'll move to the next question. So the next in this here that A is a subset of B. A is a subset of B. That means if you draw a Venn diagram, suppose this is B, A is inside it. Something it is A. It is all the elements are inside it. Okay. A elements are belong to एक छोटा सा सबसेट है जिसमें A अंदर बड़ा है. What we have to show is C minus B is a subset of C minus B. C minus B is a subset of C minus A. So let some arbitrary element X belongs to C minus B. Right? That means what implies X belongs to C and X does not belong to B. Right? X does not belong to B. That means X does not belong to B means what? This entire element, this all the elements are in this. No element of this is present in this X. X is not present in element. That means X belongs to C and X belong does not belong to A. Also A, because A is inside B. If the elements are does not belong to B, naturally they don't belong to A also, right? So does not belong to A because A is a subset of. Then what? We'll do the reverse of it. X belongs to C minus A. Correct? That's what we are written here. X belongs C and X does not. C minus B means what? X belongs to C and X does not belong to B. If X belongs to C and does not belong to A means this X belongs to C minus A. Therefore, X, we started with X and this is, we have shown that X belongs to C minus A. Therefore, C minus B is a subset of C minus A. Hence proved. Simple, right? With the Venn diagram, it is very simple. Also, algebraically, we have proved it. We'll move to the next question. Here, assume that PA equals to PB, so that A is equals to B. PA means what? PA means power set of A. Remember that PA is power set of A. We have seen in the fundamentals what is power set. All the sets containing the elements of A. Suppose n elements are there, then you will have 2 raised to n sets in A. If A is having is n elements, then 2 raised to n sets in power A will be there. But we have seen in the previous videos. Go there and definitely watch. Don't miss any of the videos. Have thorough understanding of these concepts. Then these things will be very easy. My approach is I am giving all the proofs, both Venn diagram as well as algebraic approach. Means you have to logically you have to prove that results. This is what they ask in the examination. Now this is let X belongs to A. That implies what? Implies the set, which is the set, is an element of A by definition. Correct? This is a set. Sets formed by the elements is the elements of the power set. That's what we have defined power set, right? This implies what? X belongs to PB because PA is PB given, right? PA is equal to PB. So X belongs to PB. That means what? X belongs to X element, not set element. Element belongs to what? Yes, you guessed it right. This is B. X belongs to set B. Therefore, what we have started? We have started from X belongs to A, and we have shown X belongs to also belongs to B. So A is a subset of B, right? This is one. Similarly, we can see, we can show that let X belongs to B implies the set X belongs to power set B. Simple, right? That implies this X belongs to power set A because these two are equal. It is given. Therefore, this implies X as an element belongs to A, right? We started with equals x belongs to B and we proved x belongs to A. Therefore, B is a subset of A. From 1 and 2, A equals to B, right? Now, I think you are more comfortable with the proof algebraic approach, proving the equality of the sets, proving the one set is a subset of the other, and proving finally they are equal. Now you are more comfortable. I will give you a nutshell of the important formulae in one place. Okay, in one of the videos, following videos. That will be useful. You can take a printout and keep it with you, and always refer to that. And it will be It will be very useful to while solving the problems. Keep doing the problems, and you can easily remember them, and you will understand them also. My approach is solving algebraically with logic, also with showing the Venn diagram. So you will be having the expertise in both. We'll move to the next question. Here, is it true that for any sets A and B, PA union PB equals to PA union B? Justify your answer. There are a couple of ways of doing this. See, most of the set problems will be having more than one approach to solving the problems. You best suited for you, not self. Okay. Here, the answer is no, it is not true. Why? I will show you with an example. It is false. So, what is the? We'll take a couple of sets. A equals to 1 comma 2 and B equals to 2 comma 3. These two sets. So, what is A union B? A union B is, yes, you said it right, 1, 2, and 3. Right? Now we'll see power sets. What is PA? Can you write all the sets? Yes, you should write. While watching the video, you should solve the problem simultaneously. That will help a lot. First, null set 1, 2, 1 comma 2. This is the power set of A. Power set of B, 5, 2, 3, 2 comma 3. Right? What is E A union B? 5. This is the one. A union B is right. This one. Right? 1, 2, 3, and take the combinations. 1 comma 2, 2 comma 3, 3 comma 1. And finally 1, 2, 3. Right? This is the power set. You can count them 1, 2, 3, 4, 5, 6, 7, 8. 8 elements are there. That is true. 3 elements are there. 2 raised to 3. 8 elements will there in the power set. Number of A union B. Right? That's it. Now, so what is PA union PB? What is PA union PB? 5, 1, 2, 3, 2, comma 3. 1, 2, 2 is common, so once take only once. Also, I forgot 1, comma 2. So, right, all these elements are there. Clearly, PA union PB is not equal to PA union B. Right? So, it is not equal. The statement is false. The second method is you can use number of elements of the this and the number of elements of union and number of elements of the A union B, because here the common element is that A and B are having a common element. 2 is the common element. 2. If suppose if you take 1, 2 and 3 and 4, that is A equals to 1 comma 2 and B equals to, then you will have different sets of A, A, A. You can check yourself. I'm leaving it as an assignment for you. A union PB will be 8 elements. Number of this is this thing, but number of A union B will be 2 raised to 4. You can check yourself. That is how much. So clearly this is not equal. Sometimes this number itself will decide they are not equal. Okay, this is second method. You can say second method, but I want you to probe this on your own, taking the number of elements, right? Number of elements is the elements. Okay, so we'll move to the next question, 8. And if you don't get this, leave it and in the comment like section. Okay, I will try to address that. We'll move to the next question, question number 8. So the next question is, so that for any sets A and B, A equals to A intersection B union A minus B, and A union B minus A equals A union B. The first one is A is equal to A intersection B union A minus B. Let RHS is this. Before proceeding with the proof, I want to I will show 3 important results. Understand them; they are very very useful, and also remember them. Know how to prove them also. Okay. This is universal set, and it takes two sets. This is A and this is B. What is A minus B here? Is A minus B, right? So A minus B is this. We'll take another universal set and A and B. What is B complement here? Leaving everything. Leaving B, all other is the B complement, right? This red portion is B complement. What is A intersection B complement? What is that? A common with all these things which is there. This one, right? Only this. What is that? Can you see this? That is nothing but, you have seen many times, A minus B. This piece, this this crescent is A minus B. Correct? This. So we have got an important relation here. What? A minus B equals to A intersection B complement. This is first relation. You can prove it Venn diagram with, we can prove it with taking some examples also. This is very important. Second one is, we can prove this algebraically also. I am telling this also, you can prove algebraically. But Venn diagram I proved it. You can take an example. You can prove it with algebraically also. If you want, I will make some video on this separately for this. Not difficult, but there is the relation. Remember this relation. We will be using it. Now, second thing is A union B intersection C equals to A union B intersection A union C. It is only a distributive law. Third one is union distributes over intersection. Similarly, A intersection B union C equals A intersection B union A intersection C. These three relations we will be using them. Okay, they are very important. Now, this what is this? A RHS is what? A union intersection B union A minus B. What is A? This is nothing but A intersection B. This A minus B is what? We have proved A intersection B complement. A intersection B complement. Right? This means this is what? See, you have written this A, you can see A intersection B union A intersection C. Some other three sets are there A, B, and C. Here also A, B, and B dash. So this formula in reverse we can apply this. This will be using this. This will be this is equal to this. So this is also equal to this. So we'll write this is there. So we'll write the A intersection B union C. So that is A intersection second set B union third set B dash. Okay. So B union B dash is what? B union B dash. By this time you should be knowing this. This is universal set, right? Because suppose see any the set is there. It is simple. As any set is there. B is there. This is B. This is B. B dash is all the remaining part of the universal set. So if you combine B and B dash, you are getting U. So U is B dash. So this is A. So this is what? A intersection universal set. Right? A intersection universal set is what? Universal set is there. Some set inside there. What is common with that? It's simple. Again, I'm again and again I'm telling this because you should if you by this time you will become an expert after that. A is there and this is U. What is intersection of intersection U? What is common to A and U universal set? A itself. A is all the elements of A are common to them. So A intersection U A U is A. So this is proof. This is first one. Okay. The second one. This is what? Here. Second one. LHS is what? A union B minus A. That is what? B minus A means B intersection A complement. Right? So A union B intersection A complement. Understand this. See, we have written B minus A minus B is this and B minus A is this one. B intersection A complement. Now we will use simple distributive law. A union B intersection A union A complement. Right? This is what we get. Now this is A union A complement is what? This is, you know very well, this is A union A complement E equals to universal set. So A union B intersection universal set. Any set intersects with universal set is left with the same set itself. Right? We have seen that before. So this is equal to A union B as proved. This is what is the RHS. This is RHS, right? Try to understand what are the proofs given, what are the properties are given, what are the results obtained. It will be the solution of the it will be easier. Have focus on that, and solutions will be means you can do the problems very easily. You can solve the problems very easily. We'll move to the next question. Before proceeding to the next question, I wanted to prove this also in Venn diagram, just to have you will appreciate that Venn diagram approach also. For that, we'll take two sets. This is A, this is B, and A intersection B is this. Okay. What is this? Yes, this is A minus B. Right. Now, A minus B union A intersection B is what? When you clearly see this yellow portion and white area together, it is that circle A, set A, right? So simple. In Venn diagram, it is so simple. And also the second one. This is one set. This is another set. A. B. What is B minus A? This is B minus A, right? This one is B minus A. What is A union B minus A? A union B minus A. This complete A and this blue portion. This is what? You guessed it right. A union B. The complete area of this. Okay. This is A union B. Through Venn diagram, you can show it like this. Just to show, you will appreciate the Venn diagram representation of sets. That's why I'm showing you. The proof should be algebraic. CBSE examiners in final examination, they mostly they will be asking you to prove by using the properties and the results and algebraically. Sometimes if they don't mention, you can use Venn diagram also. Okay. Next, we'll move to the next question. Now, using properties of sets, show that A intersection B equals to A and A intersection A union B equals to A. So these are very means we have seen many times these things, but we have not noticed them. But we'll be showing them with a simple proof. Well, just I will draw a Venn diagram for this for your understanding. A will make my two circles A and B. This is B. Okay. What is A intersection B? This is A intersection B. And what is A union A intersection B? A union A intersection B. The same thing, what I repeat, I have done in this previous question, I'm repeating it here. This A and union A intersection B, this portion. Again, this portion is repeating. This is A itself, right? This will be using it here. So, First one is what? A union A intersection B is what? Simply use this is distribute it. What A union A and A intersection A union B. Right? A union A is what? A itself. A intersection A union B. A union B. What is this A union B? This is what we have proved just now here. That is why I have given clearly this Venn diagram. A union A intersection B is A. Nothing but A. Got it? This is simple, right? Venn diagram, you have to visualize this. A union A intersection B equals to A. This I have given you in the previous videos. I have given you an important formula. In that I have given this. Second one, A intersection A union B. A intersection A union B equals to A intersection A union A intersection B. Okay, this is what? This is A intersection A is what? What is intersection A? What is the common in between A and A? A itself. All the elements of A are common to the other A. Okay, this is A union A intersection B. Union A intersection B is what? Again A. So this is A. So how beautiful the solution is. You see, this relation is giving you all the picture. This is not difficult. If you just visualize this Venn diagram, the relations are obvious. So उसको देख के ध्यान से देख लो. You will get solve करने में कोई दिक्कत नहीं होगा. So we'll move to the next question. Show that A intersection B equals to A intersection C need not imply B equals to C. That is the question. That means A intersection B equals to A intersection C. It doesn't guarantee that B equals to C. Okay, that we have to prove. Let us assume three sets. In set A, 0, 1 as elements, and set B, 0, 2, 3 are elements, and set C, 0, 4, 5 are the elements. Okay, we'll take the intersection. A intersection B is 0, and A intersection C is again 0. So, therefore, A intersection B equals to A intersection C, right? Here, 2 belongs to B, but that 2 does not belong to C. You clearly see that. So, B is not equal to C. So, the intersection A intersection B equals to A intersection C doesn't guarantee the set B and C are equal, right? So, we have proved B is this A intersection B equals to A intersection C doesn't guarantee, but doesn't imply B equals to C. Okay, we'll move to the next question. Here, let A and B be two sets. A intersection X equals to B intersection X equals to null set 5. A union X equals to B union X for some set X. So that A is equal to B. See here the approach is same. We'll prove A is a subset of B and B is a subset of A. Then A equals to B. This is our approach. Before that, I will give you two results to remember. A intersection A. We have seen this equals to A. Also, A intersection A union B equals to A. This we have seen in the previous example, right? So in the previous question, we have solved it. We have seen this. Now, first is given. What is given? A union X. X is a set, not an element. Remember that. B union X is given. A intersection. What we can do here is we can add A intersection on both sides, LHS and RHS. You can do that. The equation doesn't change. A intersection I am changing on both sides. So what is A intersection? A union X equals to A intersection B union X. We are adding A intersection on both sides. This is what A intersection first set and second set equals to A. Here first set is A and second set. So this equals to A. A intersection A union X is nothing but A equals to, you can expand this, distribute to A intersection B union A intersection X. What is A intersection? A intersection is nothing, is 5, right? So A union A intersection B. This is nothing but, this is A intersection B. That means what? A equals to A intersection B. See, this is A intersection B. Suppose A is there and B is there outside and A is inside. A is completely, A intersection B is A. Means what? A is completely inside B. A is inside B. That means all the elements of A are inside B. A is intersection B equals to A means B. So A is a subset of B. Right? So similarly, we'll see. So A union X equals to B union X. So we'll add B this time. B intersection. We'll add A union X equals to B intersection B union X. So this becomes what? B. This is what? B intersection B union X. First set. This is the same. This is in the same pattern. So this will be B. So B, we can open this. B intersection A union B intersection X. Right? This is what is we are distributed this intersection over union. Exactly, we are repeating the same. This implies what? B intersection A union. But this is what? B intersection X. X is what? Null set. This is nothing but, this is B, right? This implies B intersection A B intersection A equals to B. This means similar to this. A intersection A is equal to A equals to A intersection B means A is a subset of B. So that means here B is completely inside. B is inside A, right? So this implies B is a subset of A. You can say this is 2 and this is 1, and from 1 and 2 A equals to B. Okay, this is how we proved. This is approach. I will show you A. This is what this is. These are the things given, and we have to show A equals to B. For showing A equals to B, we are going to prove A is a subset of B and B is a subset of A. Then A is equal to B. Now given is these things, and we are adding A intersection on both sides. And some maneuvering. After that, we will prove A equals to A intersection B. A equals to A intersection B is, that means A intersection B is, A is completely inside B, then A equals to A intersection B. So A is a subset of B. Yeah. Similarly, B is a subset of A. So we'll prove, can prove A equals to B. Hope you understood this. That concludes the video, and we'll meet you in the next video with the solutions to the miscellaneous exercise from uh, question number 12 onwards, and we'll finish the exercise in the next video. I think you are following this. Please like and comment and share with your friends and classmates. Thank you very much.